Good morning, folks. So today we're going to briefly talk about Explore Engage 2, which is about quantifying electricity. Now, in the previous day, one of the things I did was sort of talk about the relationship between current and resistance and voltage, and sort of this example of the your water faucet. And today I just sort of wanted to sort of go into the mathematical relationship, because what you're going to be doing today in Explore Engage 2 is you're going to be going through sort of answering some conceptual questions and then using one of these three equations to then answer some questions and solve some problems. So with this, basically the idea is you have your voltage of your, so that would be like the water pressure in the faucet example, equals the current, so the flow rate, the amount of water coming out of the faucet, times the resistance, which is how on your faucet is. And so when you rearrange it, you can rearrange it to your current equals your voltage divided by your resistance, or your resistance equals your voltage divided by your current. Now, you're going to end up using this at the end of this section to sort of solve some problems. And so what I'm going to do is we're going to go over the sample problem in just a minute. So one of the big things I want to go over right now is the login for the book. So over on these ones under the assignment and task / description, these are links to the direct chapters and sections that you will need to do the reading. However, the ebook is a little bit weird, and so one of the things you have to do first is you have to log in to your ebook. When you get to this page, remember, if it might already pop up with your login, but just to remind you all, you choose the state as California and you choose the district as Alameda Unified School District. And then you click next, and then it'll bring you to this part. You'll put in your username and password. Your username should be your email. Your password will be ACLC, all lowercase, and then a 2-digit number. And then once you sign in, you can actually even just go back here and then click on the link, and bam, it brings you right to where you need to be. I think I clicked on the wrong one. Yeah, I must have messed up that. Oh well. So what you'll end up doing is you'll be going through here. You'll be looking at how different things affect it. Like in this first example, you'll be looking at the comparison of current through between a copper tube and a nichrome tube. The nichrome tube, of course, has more resistance, which you'll read about, and then you'll sort of answer a few more questions about what does it really mean to have more resistance. And then as you go on, it'll talk about how we use things such as like tungsten and all that in heating element wires, and sort of like the coils of a toaster, or if you have a space heater, it's a similar property. And then further on, you sort of look at the mathematical relationship between the two, and sort of how in a circuit, the current is going the opposite direction of the electrons, which sometimes feels a little bit about of counterintuition. However, and then you're sort of doing some direct mathematical relationships, and then finally being like, oh, which equation is it? Well, I already provided that for you, so that's good news. Alright, so when you get down to using the problems, I'm going to actually go through the sample problem with you all. So let me pause this first. Alright, so in this sample problem, we have a circuit containing a battery and a light bulb. It says that the light bulb has a resistance of 3 ohms and the battery has a voltage of 1.5 volts, and then we need to find the current in the circuit. So since we can make a table, kind of like what they did there, where you have your knowns and your unknowns. So we know that the voltage is 1.5 volts, and we know that the resistance is 3 ohms. And then the unknown is the current. And so what we would do is, if we look over here on our thing, we have voltage, current, and resistance. So since we're looking for current, we can start with this one where it has the current already solved. So we can sort of do this problem as such. So we have I equals, and then our voltage, which it says in the problem, is 1.5 volts. And then that's going to be divided by the resistance, which is 3 ohms. Now ohms use a weird symbol. It's the omicron, and so that the omega symbol, I should say. So we use omega symbol, which is basically looks like a horseshoe for resistance, and then when we do the division, we end up with, which you can use a calculator if you really want to. And it's good little mental math because this is half of this, so we have I equals 0.5 amps, which we just use the symbol A. So we just sort of solve that problem by plugging in our voltage and our resistance into this equation and solving for our current. And then what you're going to do is in the rest of the problems, there are 5 more or 4 more that you're going to do. The first 3 you're finding actual numbers, and in number 4 you are sort of doing an analysis where you double your current and the current stays the same, you double the voltage. What has to happen to the resistance in order for that to occur? So it's sort of looking a little bit deeper into how these equations work. And that is all for lesson 2. So what we'll do is I'll end this here. If you have any questions, feel free to message me on either the Discord, Jupiter, or come to my office hours, which I've set up between 10 and 11 and 1 and 2 every day during the week. All you have to do is just message me on Hangouts or email, and we can set up a time to meet via Zoom or Discord or something. That's all. Have a good day.